many opportunities to work with a first grade classroom over the course of a school year, and in this particular class, the students were spending a lot of time working on place value ideas and building their understanding of two-digit numbers. So we're going to see a video of Mrs. Brannon, the classroom teacher, as she's working with kids on developing some of these ideas. She's going to pose a word problem to these kids, basically a 7 groups of 10 word problem, and it's based on a story that they've just read recently called Creepy Carrots.
Jasper Rabbit finally built 7 fences to keep the creepy carrots in. Okay? There were 10 creepy carrots inside each fence. How many creepy carrots is Jasper trying to keep in? Okay, no, I'm going to read it again. Jasper Rabbit finally built 7 fences to keep the creepy carrots in. There were 10 creepy carrots in each fence. How many creepy carrots is Jasper Rabbit keeping in? Okay, so what do we know? How many fences did he build? 7.
So this creepy carrots word problem is in essence asking, how much is 7 tens, right? And that's a multiplication grouping word problem for first graders. I think that's pretty exciting.
In recent times, I hear a lot of discussion about content limits and the standards, and I think in a lot of places, multiplication and division have been pushed back to sort of 3rd grade and higher in the curriculum standards. But it seems like in this lesson, it's essentially a 7 times 10 problem, or 7 groups of 10. But what I hear, what I think we're saying here is that in this context, really place value and multiplication and grouping by tens and so on are sort of all integral in one piece.
Absolutely. These kids are not viewing this as a multiplication situation, although as adults we see it as a multiplication situation. What they see it as is an opportunity to make groups, to make these groups of 10, which is such a huge idea well before 3rd grade, where multiplication and division really start popping up in the standards in a much bigger way.
A problem like this is an opportunity to find out what children understand about place value, about how much is 7 tens.
So after Mrs. Brannon posed this problem to the kids, she of course wanted to make sure that they all understood the story and what they were going to get ready to start solving. And she moved among a few of the kids and interacted with them differently based on where their understanding was of place value.
How many fences do you have? 7. All right, so let me ask you a question before you ever even start. You ready? How many carrots are in each fence? 10. Okay, so what's your plan here? If you already know that there's 10 in each fence, what's your plan? Are you serious?
Interesting that she stops him before he even starts and asks that key question, what's your plan?
Yeah, and that is a real key question. Something that she knows about Gunnar and that I got to witness in looking at Gunnar is right on that cusp of thinking in 1s to thinking in 10s.
So she's really helping him to stop and not just do what he's done on other problems like this, but to try to kind of see if he thinks about it, if he can take that leap to a thinking in 10s strategy.
How many carrots is he keeping in?
70.
Gunnar, why are there no circles inside of your fences today?
Because there was only 10, so I couldn't count them back tens.
Okay, so you didn't need to take the time to draw 10 circles into every single fence, did you? Because you already knew when you heard there were 10 that you were going to count how? Count for me.
10, 20, 30, 40, 50, 60, 70.
It's okay, don't worry about that part. Okay, don't worry about that. We'll just mark it out, okay? Because I heard you say 10, 20, 30, 40, 50, 60, 70. So how many groups of 10 do you have?
7.
7. So 7 groups of 10 is the same as what? 70. What if I only had 5 fences with 10 in each fence? Okay, Okay, and I saw you say, what were you saying? So 5 groups of 10 is, 5 groups of 10 would be 50.
It's almost like the teacher was trying to help reinforce the idea that she doesn't have to count by 10 to know it, sort of moving toward that sort of understanding that 5 tens is 50 and 7 tens is 70. But it does seem like Rayleigh is kind of hanging on to that sort of 10, 20, 30, 40, 50, 50, right?
Yeah. Well, maybe it might be worth pointing out something about Rayleigh. She routinely counts by tens on these groups of 10 word problems.
And again, following the fact that Rayleigh just determined that these 7 tens made 70, it seems really natural to say, well, what about 5 tens? To see if she could make that leap
So
to...
generalizing that idea.
Right, right. And it wasn't about a bigger number, it was about something that maybe she could hold in her mind and make sense of.
So after the students had a chance to solve this problem, Mrs. Brannon wanted to lead a class discussion where different kids were sharing their strategies. And she was really intentional with which strategies she selected to have shared so that the entire class was engaging with that thinking and really making sense of some place value ideas that they still needed to learn.
See if you can decide what decision she made after she drew her picture by ones. Drayden, what decision did she make?
Count by tens.
How can you tell that she made a decision to count by tens?
Because she said 10, 20, 30, 40, 50, 60, 70.
All right, now Jayla, is that the decision that you made to count by tens? Why did you make that decision?
Because that would be a lot faster.
Okay, it was going to be a lot faster. What was your other choice?
When I thought it was like 30, I X'd out.
So what were you going to have to do if you didn't count it by tens? You would have had to have counted them longer. Because guys, how would she have been counting them? By one.
Najela's strategy is such a great one to open a discussion with, because with all of those creepy carrots drawn out in each of the fences, and each of having 10 creepy carrots in each fence, it pulls along those kids who are still really thinking in ones. They can see all the carrots in Najela's picture, but then helping them to think about, well, this is a group of 10, and even though I have 10 individual carrots in each of my fences, I can count this by tens, is starting to kind of move them forward.
And Najela knew that, like, she wanted to count them in tens. I loved her language about it. If I were to count a different way, it would be longer. Like, I think that's interesting that she knew that. But you're right, the teacher sort of bringing her in and letting her explain how she counted in tens to sort of get to the answer was important.
And it was probably reinforcing to her. If she's just moving toward this starting to count in tens way of doing things, choosing her, letting her be the one to get up and to show that counting in tens strategy, she's probably really proud of it. And it's really a new thing for her.
Gunnar, I came back and wrote these tens in here, right? And after we did that, we knew that there were 10 here, 10, 10, 10, 10, 10, 10. How many groups of 10, Gunnar, did Jasper have? How many? Do you guys agree that there's 7 groups of 10?
Yes.
Can we check to be sure?
Yes.
I want everybody with me to check to be sure. There's 1 group of 10.
2 groups of 10. 3 groups of 10. 4 groups of 10. 5 groups of 10. 6 groups of 10. 7 groups of 10.
And I can look underneath it and tell that he counted his 7 groups of 10 and found out there were how many carrots?
70.
70. So how much, Carly, how much is 7 groups of 10? 70. Chloe, I need your paper for a moment. I just need part of it. So Chloe, just look at her picture real quickly. Whose strategy does that look like?
Gunners.
Looks just like Gunner's. Okay. But I asked Chloe then to go down here, and I want us looking at this one. I asked Chloe to write an equation that represented her problem. And I'll let Gunner's work up there because they did it the same way. Now here's what I want to know. I see a bunch of 10s. And I want to know, how in the world did she know when to stop writing tens, because I feel like I could probably just do this. I feel like I could just be like 10 plus 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 10. How in the world did she know when to stop?
The final image that's on the screen is so intentional and deliberate and carefully constructed between those 7 circles with 10s in them, and then 10, 20, 30, 40, 50, 60, 70 written right below them, and then 10 plus 10 plus 10 plus 10 and so forth equals 70 in that equation. And then it wasn't even mentioned in the video, but then below that, 7 times 10 equals 70, and it's all laid out right there in this sort of sequential order in these different representations of this same idea.
Yeah, I think this pedagogical move of putting them all up there together is reinforcing this idea of this integrated understanding of tens and ones, right?
So, having spent the first half of the year working on place value ideas and conceptions of 2-digit numbers with her first graders, Mrs. Brannon was really curious to see how they would generalize those same ideas to 3-digit numbers. So again, she uses a groups of 10 word problem with her kids, because those tend to be really effective tasks for kids to engage with. So look at these 2 problems. First one, Kylie has 160 fish. She put 10 fish in each tank. How many fish tanks does she put fish in? And the second word problem, Kylie has 16 fish tanks. There are 10 fish in each fish tank. How many fish does Kylie have? So she gave that to the kids. Basically, what is 16 groups of 10 to her class. What was interesting is the variety of strategies that these kids used. We had many kids that represented the 16 tens using some kind of manipulative or drawing, like Jaden did. We also had students that counted by tens 16 times, like Laura did. And what's interesting is these kids like Jaden and Laura, on problems where the numbers were lower, like 8 fish tanks with 10 in each, both of those kids would have just said 80. But this problem provided an interesting challenge for them, moving the same ideas into 3-digit numbers. So in this next section, Mrs. Brannon wanted to have her class really focus in on a different strategy from these previous 2, to look at Chloe's strategy.
8 tens, 9 tens, 10 tens, 11 tens, 12 tens, 13 tens, 14 tens, 15 tens, 16 tens.
So she's got 16 groups of 10. Fabulous. Now you don't say a word. I want you to see if you can figure out why. She could have just piled all 16 tens together. Why did she choose to draw it like this? Talk to the people at your table. Why did she choose to draw it like this? Groups of 10.
The one from the 10 groups of 10 and the 6 groups.
Clearly, Miss Brennan wanted to highlight that in this conversation. She made a big point about drawing the students' attention to why Chloe might have done that.
And moving students from understanding that 10 ones can be 110, kind of iterating that idea, taking it to the next step, and recognizing that 10 tens is 100 is huge. That's the next level. That's where a lot of these kids seem ready to go.
Yeah, I think you're right. I think the teacher's demonstrating that flexibility of thinking about 16 in this case as 10 and 6. Earlier we talked about thinking about 16 in lots of different ways, but in this example, it's convenient to think about 16 as a 10 and a 6. So while there's lots of really great place value tasks that Ms. Brennan has engaged her class in throughout the year, I think these videos highlight 2 maybe underutilized ways to engage kids in place value, which are these groups of 10 word problems.